Welcome your faces back to episode number 56 of the series Profit or Loss. I take faulty electronic items on eBay, attempt to fix them and sell them on for a profit. As you can see from the screen, we are on a little bit of a roll. Our total profit now sitting at a very healthy £327.60. But me personally, I know what this game is like and it's probably not going to last long. Speaking of the game, I have made some upgrades. As you can see up in the top right hand corner now, we have a digital multimeter. Big shout out to Console Therapy. I was watching one of their videos, they had it and I was like, I would like this please, can you tell me more about it? In which they did. So let me introduce the XDM1041 digital multimeter. An affiliated link will be down below in the description, but that is not the only upgrades we've made. Please welcome our Metcal soldering iron. One of the tips is a conical tip, as you can see here. The other one is slightly more flat. I used Metcal when I used to work at Rocket Repairs, and trust me when I say that these tips are fantastic. That doesn't mean that I'll be getting rid of my Hakko FX951. It simply means that I'll be adding the Metcal as more of a micro soldering option. Shout out to my old boss at Rocket Repairs who gave me the Metcal station. On the note of the stuff that I used to use at my old job, these are Hakko Omnivices and they are essentially board holders. Quite expensive for what they are, nonetheless needed upgrades. We say, Joey, no more waffle. What have you got for us in today's video? I have a Nintendo Switch Lite that I paid a grand total of £50 for. Condition of it isn't horrendous at all, it just needs a good little clean. We'll take off these like poor button things, which has actually kept the condition of the analog sticks very, very good. SD card? No. Game card? No. Screws? Looking good. Charging port? Okay. Doesn't look... Oh, no. Oh, dear. This screw looks good as well. I don't think this console has been opened before from what I can tell, so we are lucky in that sense. However, I do see what looks to be a slight bit of corrosion / water damage there. So instead of putting our trusty old ammeter in to measure this, let's just take it apart, get it down to the board and see what condition this is in. However, before we do that, a quick word from our lovely sponsor, PCBWay. PCBWay is the solution for all your PCB needs. Imagine this scenario. You're in dire need of a reliable service to print some custom circuit boards. Those boards need to be great quality, have fast shipping and be at a very good price. PCBWay have you sorted. Simply start your instant quote and customize your PCB to how you want it. Anything from thickness to solder mask color. And then in a few simple steps, you'll be ready to check out. PCBWay also offers services such as CNC machining, 3D printing, injection molding, and sheet metal fabrication. Why not check out the gift store where you can buy preheaters, soldering irons, multimeters, and much, much more. Head on over to PCBWay.com to get started. I have, however, just noticed that we have some wording on the back of this device and it says Old Roy or something. Oh no. That's not coming off. I think it's like some sticker residue or something. All right, well, I'll have to investigate that in a bit. I've gone through the liberty of actually taking the board out of the chassis, and we can see that we've got a small bit of corrosion here, liquid damage. I'm pretty confident to say that's just going to rub off with a little bit of a clean. Same around the battery connector. Again, that's fine. The water damage indicator has turned pink, so it does show that this area has been affected by water damage. Let's just have a quick look around the board. That doesn't look like it's been affected in any way, shape, or form, which is always nice to know that the Max IC is untouched. The rest of this side of the board seems to be absolutely clean. Let's turn it over. Whoa, whoa, whoa. Alrighty then. So this right here is our little fuel gauge. So this will most probably need to be changed. We have a cap here as well that will most probably need to be changed. But I'm going to give this area a clean up. Maybe we just have an issue with the fuel gauge, which is why this isn't turning on. You can see where the liquid damage is coming down here. Look, through the port onto the back, just around here. M92T36 and BQ are quite clean. I think I may have got really, really lucky with this Nintendo Switch Lite, if I'm honest with you. If it was left much longer, this would have spread and it would have been 10 times worse. But other than the places I've just shown you, the rest of the board is relatively clean. So I think we're going to get away with this, you know. Right, plan of action. Remove said charging port and clean up the corrosion that we have here. I'm going to go ahead and replace the fuel gauge anyway because there is corrosion definitely underneath the IC and it's a BGA, so we're going to have to get another one. Replace that cap, that resistor, and potentially that cap, although that cap might actually be okay. We'll measure it. Should we, for the funsies, and for the sake of our new multimeter software, measure around M92 whilst the port is on? I'd recently just spent quite a bit of money on a Fluke multimeter. However, I do wish that I purchased this a little bit sooner, rather than me just randomly calling out numbers. You can now see them on screen. Let's put our multimeter into continuity mode. The threshold itself is 50 ohms. So for example, if I put my multimeter here, it's not going to beep because we don't have a resistance of under 50 ohms. However, if I go to ground, it's going to beep. Do we have any shorts around M92T36? The CPU cap, how are you looking? Coming up 500 ohms, that's not a horrendous reading. Okay. Everywhere else seems to be okay. So, by some miracle, we don't have a short on M92T36. However, that cap coming in at 550 ohms, I'm not too sure at the moment. But that might be because of the situation we have down here. If I measure here, wow, we don't have a short here. I'm actually I'm actually pretty shocked. Let's measure it around BQ. So we just check there and there. That's ground. That's okay. And that's okay. All right, what's the situation on our fuse? Yeah, we have a continuous path, so our fuse is good. It's probably just going to be around this area then. And the fact it's maybe not taking a charge because of the state of the actual charging port itself. So, charging port off, sort this area out. And this is a prime example of where our board holder is going to come into play. Simply secure the board in the vise, not too tight, turn it round, 450 degrees Celsius with an airflow speed of 50%, and we're just going to take this port out. So clear that heat. I've got a very, very, very sweet smell in my nostril right now, that is for sure. Okay, the port is loose. However, we don't want to rip any traces, so I'm just going to let it fall freely. Just like that. There we go. Let's go over to the microscope and see the damage. How are we looking? Okay, looking all right. This side, we just need to quickly remove some stuff. So I'll do that whilst I'm here and I've got the hot air gun out. Exactly the same temperature here. Just going to grab this off the board. There we go. And we'll take this. I think that cap is going to be okay. This one, not so much. So we'll take this off as well. There we go. Let's scrape away this bit of Coca-Cola or whatever this is. Take it out of the board holder. And now we're going to give this area a nice clean. Make sure we get rid of any of that corrosion. There we go. Look at that. All right. I just use a bit of isopropyl alcohol. Give it a nice scrub. There we go. It looks 10 times better, hey, than what it did. We don't want any of that corrosion left over to cause any issues going forward. Scrape off that little bit from the metal there. All right, we'll come in with a little bit of fluxy just here. I'm going to use the Metcal soldering iron, and I'm going to use the thin tip, see how we get on. I'm just going to place a little bit of solder here. Just go over those, go over that. There we go. Now we can wick that away. I think there's a couple of blobs here as well that could do with some leaded. Yeah, there and there. Perfect. What we'd like to do here is now come in with the Hacko with the flat tip. Get rid of the solder that we have on the pads of where the fuel gauge was. So we're just going to push down here. Hopefully that's going to do its work like it did. Look at that. Just to be safe. There we go. Looking fresh. Board's still hot. Can we clean up that flux? Yes, we can. Tiny bit of IPA. There we go. Looking good. Looking a lot better than what it was, that's for sure. Now we need to get a replacement fuel gauge, a cap and a resistor, I think. So no more. We have this donor board here looking okay. Now we're going to remove it from here. 450 degrees Celsius. Airflow speed 50%, exactly the same. So this is going to be our donor. So we're just taking this off. There we go. Go over to the board we're working on. And whilst I'm here, I'm just going to quickly transfer those components over that I was talking about, that cap and resistor. Here be the cap. Here be the resistor. Wicked. Now, this component is microscopic by all means necessary. There we go. A little bit of flux. Come in with our Hacko and just dab it on top. Should be clean. Yeah, there we go. There it is. Take our little chip. Again, this is called the fuel gauge. Stencil over the top. Put it in the correct position, which is there. Clamp down with our tweezers and use our little shovel here to just put some paste on the chip. Like that. Come in with our hot air. Now, I do this relatively quickly at 400 degrees Celsius and 50% airflow. Because it's such a small IC, they turn into balls very quick, as you just saw. Then we just push through, pop it out. To be safe, I like to put it back in the stencil, apply a little bit of flux and just flow the balls. If you're interested in any of this equipment, by the way, the links are down below in the description. We're only at 350 degrees Celsius now. Now I'll put the flux on with an airflow speed of 30%, just to make sure that those balls are on the IC, all soldered properly. And now just a very quick clean with some IPA and a toothbrush. Being very careful here that I don't lose the chip forever. So the little arrow that we have, dancing around, the little arrow that we have on the board, which is down here, indicates pin 1 of the IC, which is actually symbolized by this plus in the top corner. So what I'm going to do is just make sure that this is down. Grab it with my tweezers. 450 degrees Celsius, airflow speed 50%. Method behind my madness. That should be tacked down now, so I'm just going to come off the heat. Give it a little wiggle. Yep, that's down. Now I'm going to apply some flux. Flux I'm going for here is V3TF. Lower the air to about 30% to keep the flux spread at a minimum. And we're just going to hopefully now flow this in place. That jumped very far, so I don't know if this is going to be okay, if I'm honest. We'll see. Let's give it a little bounce. Okay. I don't know if it's going to be okay. We'll see. It was very, very out of position there. Did you see how it done a hop, skip and a jump from about here to here? That's bad from me. It's not good. One thing I could have done to actually rectify that situation is compare it to a board that already has a fuel gauge on to see if my alignment is correct. But I didn't do that stupidly. Maybe it's all right. If not, I'll have to replace it. Isopropyl alcohol and a nice clean with the brush. Get rid of that flux. Okay, good stuff. How are we looking? We're looking all right. Position-wise, we might have got lucky purely because of the fact it's a very, very small BGA. If this was a larger one, we would have been out of luck. Back to the actual charging port here. I have checked the battery and that seems to be fine. So we just need to give this area a nice quick clean. Get rid of any corrosion that we have. Coming in with our flux just here. We're going to apply leaded solder with the unleaded that we already have on the board. For the sake of it, I'm actually going to use a really thin tip on the Metcal and see how it performs. It's not a good tip to use because of how big the ground pads are, but I'm going to see how it puts up with it. Give it a little bit of a test, you see. So we just place some solder here on the end. It's done a good job with those. Really, really good job. Really good job. How does it fare with this? Look at that. There must be so much heat going through the end of this iron tip. It's really, really nice. Metcal has been in the game, from my understanding, for a very, very long time. And the iron that I'm actually using is quite an older one. But the job that it does is insane. Considering how big the tip is, against these ground pads, phenomenal. There we go. Wipe away our excess flux that we have. Remember to keep the board nice and clean. As clean as we can. Now we're going to use the drop method to put the port on. As always, recommendation is to tin the port. Doing this a little bit freehanded at the moment. It's a bit awkward. There we go. How's that tin port looking? Looking good. Put some flux on. We'll spread this out. We don't need too much. Thin it just a little bit. There we go. Exactly the same on as it was off. 450 degrees Celsius. Airflow speed 50%. Rotating that heat as much as possible. Honestly, having this Hako device to hold the board makes my life so much easier. Rotating that heat and waiting for that solder to liquefy. There we go. Come in with the port and just drop it in place. Now we're going to give it a little push down. Make sure it's nice and snug in there. Nice and comfortable all around. Still rotating that heat as much as we possibly can. And I like to give it a little jiggle jiggle. Again, just to ensure that it's all cozy. Right, I'm just going to give it a slight push down, ever so slightly, nothing too much. And I'm going to come off in 3, 2, 1. Come off the heat. I'm not really pushing down here. I'm just simply resting the tweezers almost on top of the port and giving it the tiniest bit of pressure just until that stuff solidifies, which it is now. Solidify, solidify. Lovely jubbly. Right, let's check the pins before we do that. Nice clean whilst the board is hot. These are Nintendo Switch Lite ports, by the way. I've started using these instead of having to cut down the original Nintendo Switch ports, and it's so much easier. Have a look on the back. We've got a massive blob there that we'll sort out. Just go over that real quick. You can see that the plastic is ever so slightly singed on the back, but that's fine. Tiny bit of flux here just to take that absolute molehill away. There we go. Now, because I've taken that solder away, it's not affecting in any way, shape or form the structural integrity of that ground hole. Just for my sake, makes it look a little bit nicer. And there we have it. Back of the port. Now we're going to test these pins, but they all look very good to me, except for maybe the one right on the end over here. But that port is pretty much flat to the board. Yo, just stab myself with the tweezers. Let's check and just make sure these pins are solid. Make sure we're pushing the pin. There we go. They all look solid, and you can see that they all look connected as well. Good. That one and this one, yeah, that's fine. Okay, this one's ground as well, but I mean, that is connected. Right, sweet. In this scenario, because we didn't have any shorts before we took the port off, I don't think there's going to be a need to check again with the multimeter to see if we now have any shorts. So I think it's time to just give this one a test. All right, just quickly checking it without any chassis attached. What I need to see here is 15 volts, as well as a draw of starting at maybe like 2 milliamps, up to 4 milliamps, and then switching off. That's what I kind of need to see. What do we get? We get something. We get 15 volts, 2 milliamps. Staying at 2 milliamps. Okay. Take it out and put it back in. See if it does the same thing. 3 milliamps. 5 milliamps. Off. Back to 0. I need that to kind of go back to 0. It's gone up to 6 milliamps. 5 milliamps. 0. That to me shows that it's drawing current of some sort. Try the other side. 0.02. So again, we're stuck on that 0.02. I don't think this is good news, if I'm honest. This should reset to 0. Now on the CPU cap here, I did have 500 ohms, didn't I? So I'm just going to check that in resistance mode and see what we get now. Do we still get 500? No. Okay, so we get 6K, 10K, 12K, and climbing. So I think that's actually fine. Just for the sake of it, I'm going to quickly check and see if we do have any shorts. No, we look okay. Just checking around the fuel gauge, and the fuel gauge actually looks okay, to be honest. Doesn't look like we have any joined solder balls. Just looking here. All right, whilst it's not my usual reading, I'll put it back in the chassis and see if we get anything. Maybe I'm overthinking it. All right, I've connected everything that I think I need to connect. So we'll see what happens. Here we go. Going to plug it in. All right, we get something. 0.08. Do we get a display? 0.08. Nothing on the display. And 0.08 amps. Curious to actually see if anything's going to happen and if it's going to charge the battery. Regardless, we should have a display up here saying that the battery's charging, but that's not happening. Good thing in this scenario is that the CPU cap underneath the M92 or to the side of M92 T36 looks pretty healthy. So this is definitely going to require a little bit more investigation. Sat here thinking about life and it has jumped up. I'll be curious to see if it actually restarts and turns the device on, but I'm not going to be able to see that for a while until the battery is charged. But maybe we have an actual problem with the screen then, because that is pretty healthy. What's just happened? Just having a look on this connector here, because it connects the daughter board to the main motherboard. I don't know if we have a slight burn mark perhaps here. Disconnect the battery. All these pins look okay. Sometimes these diodes can go and fail to provide a backlight. And like I said, the backlight is this one, I believe, on the daughter board. And it looks pretty healthy if you ask me. Doesn't seem like there's any signs of corrosion around here or anything like that. Nope. Make sure the connector for the LCD is plugged in fully, which it looks like it is. Ignore this absolute madman. That is the FPC connector for the digitizer. The other one to the south of it is the LCD FPC connector, which is also looking fine. Let's just reseat the cables because you never know. Check under, make sure we have no water damage on the ribbon cable, which we don't. There's no water damage there. Ribbon cable itself looks pretty healthy. The connector looks really healthy as well. Make sure that's definitely all the way in, which it is. Looks good to me. Secure the clasp, and I'm sure this one down here is the digitizer. Again, just reseat, because why not? Another quick test, I say, just to make sure. All right, here we go. Plugging it in. 360, 470. Nothing on the screen. Okay, let's put it in DC voltage and see if the battery is actually charging, shall we? What we got? 3.86. Yeah, you can see that's climbing. So it's definitely taking a charge. And it means it's going to turn on soon. I'm going to try the motherboard in a different chassis. What that's going to do is going to tell me if this LCD is actually any good or not. Sometime later, I put it into a different chassis just to see if we get anything on the screen. Here we go. Is it a board problem or is it a chassis problem? Let's see. 3, 2, 1. Plug in. 0.07. Do we get anything? No, we don't. And the good thing about doing that, I guess, as well, is that it's a different daughter board. So we have a different daughter board over here on this chassis. So that rules out the actual backlight being faulty. So it's the display itself on the motherboard which has an issue. Alright, I'll be honest, I can't even really remember at what point I got up to. The switch, even though it went from 0.08 amps up to 460 to indicate a healthy charge, it doesn't want to turn on. The battery itself is on 4.1 volts, which is more than enough to be able to turn the console on. I've spent the last however long looking into the backlight circuit where I don't think that's the issue because the switch isn't initiating. So I think we have a standard case here of 460 to 480 milliamp hours, but no power. And again, like I stated, the good news is that CPU cap is okay. So I'm going to continue looking over the board to see if I can spot anything a little bit weird or strange. I've really tried to make sense of it all and I've measured everything and can't see anything wrong with anything on the board. I don't think the fuel gauge is the reason why it's not turning on, but I will change that next. But firstly, I'm going to remove M92 T36 and replace that just to see if that makes a difference. 450 degrees Celsius, airflow speed 50%. Okay, has that change made a difference? Plug in the ammeter, we still get the same reading or not? It's not drawing current anymore, but I expect that to go up and then down. Try again. 0.01. Okay, it went up and then down. Let's try this side. 0.01. Back down to 0. Alright, maybe it was just shorted internally. I'll put it back in the housing and see. Did we take an educated guess and was M92 T36 just shorted? Let's have a look. 3.7, 0.47. Still nothing on the screen. Any change when we push the power button? No change at all. Okay, back to the drawing board. Okay, I am just going to replace... Oh, solder ball on the end of my finger. I'm just going to replace the fuel gauge, just in case I did mess it up a little bit. Okay, I've checked to make sure I've got it in the correct position. I think that's good. Add some flux. Go for the reflow. It's a little bit out again, if I'm being honest. Has that made any difference at all? Fuel gauge replaced. Oh, dear Lord. Why is that bit of solder so far up? I think I'm going to have to do that again. So let's do it again. I think this little bit here is, oh, again, a bit too much, is what's causing us an issue. I'm missing a component here. I'm pretty sure that hasn't always been missing. I'm just going to spread this out and make sure it's not going to interrupt the chip in any way. Put this one on first because it's tiny. Play it into place. Nice. Tiny bit of flux. I went for a reball because I didn't feel comfortable with the paste. I'm going to go 400 degrees Celsius with an airflow speed of 1% here. These are 0.3 millimeter balls, by the way. I'm going to add a little bit of flux here. Quick clean. See how it does. Let's get it into position. Okay, come off on the board. Perfect. Hopefully this one's sat a little bit better. Let's see. Okay, it's in a good position. Just going to tap it. Looks good. Nice clean, and hopefully fourth time is a charm. One we're looking at is here, by the way. Looks flat. When I say flat, all sides have the same amount of lift to them. Yeah, looks good. All right, let's give it a test. Well, this one has sent me around the houses a little bit today. Hey, hopefully we can get it sorted and fixed. Without going through the stress of reassembling, etc., I'm just going to test as is. And if we have 0.02 or 0.04 and it stays like that, it's not good. Go up to 0.05, same thing. So 0.02, look. And it's not disappearing. Right, this side. Any different? 0.02. It's just drawing 20 milliamps for whatever reason. All right, well, time to make another educated guess, I think, and just go with BQ and see what happens. I just want to confirm as well, I don't have any shorts around the max ICs on the board. Check our work, as always. Make sure we've got a solid connection, which we do, on all sides. Perfect. Now we test. All right, don't stay on 0.02. Show me what you got. Come on. 0.03. 0.06. Shut off. Okay, so now it's just on 60 milliamps. But the board is still, I'd say, not boiling, but still hot. Definitely worth me mentioning to you as well as, again, recording Joey. I did use the thermal cam to see if anything was getting hot, but it was just the standard BQ. Getting a little bit warm is all. Why, though? Why? This has haunted me before, by the way. On a live stream I did once, I was scratching my head for such a long time. I didn't actually get round to finishing it. I pretty much changed out every single component going. What I will confirm as well is one of the main areas I was focusing originally was around here on this circuit, and I can confirm everything is measuring as it should. Every single component. Here we have D plus and D minus. The port itself is missing 2, but it does on the switch light. I think it's A8 and B8 because it doesn't have P13 USB connected. So we're not meant to get that. It's meant to be open line. But everything else seems to be no issues at all. It's a very tricky one. Very, very tricky one. Could end up being a NAND or CPU problem, but we'll double check everything anyway. I mean, look, if I go on here, you can see on the screen. So we've got 0.51 there, 0.4 there. This is in diode mode, by the way. 0.53, 0.54. On this pad here, 0.49, 0.4, 0.48. So everything checks out around this max IC. We get a really low reading here. In diode mode is 0.0063. But if we switch over to resistance, we should have around about 10 ohms or so, which I think is what I've measured before. Yeah, 11 ohms, 12 ohms. And then if we go over to this max IC on the back here, we've got ground here, that's 0.05. So this is going to be where that 12 ohms is, which is perfectly normal. This is ground. Here we get 0.0, but that's, again, that's accurate. Nothing there, that's ground. This one, yeah, 0.12. This pad here, 0.015. Now this little chip here, this ENJR, can also be found on the Nintendo Switch, which is up here. And I've had this cause some issues for me before. There are no signs of liquid damage around here. However, that inductor does look a little bit burnt, doesn't it? Does that inductor look burnt to you? So in diode mode, let me just check around here. 0.4, that's ground, right? Yeah, that'll be ground. What's this? 0.07. I don't know if that's accurate. What do we have on this side of the inductor? 0.33. And this should be 0.33 as well. Yeah, it is. So what's this about then? 0.4, 0.06. Take a donor board here. 0.06. 0.074. 0.77. 0.06. Tiny bit different, but nothing that I'm really worried about. I'm going to change it out. I'm going to go with this one first and see what happens. It's worked for me before changing this over, so we'll see. I don't think there's another one on the board. I hope not, because I'm taking off the wrong one. I'm sure this is the one that we can use to reball. This is what I've been waiting for. Here we go, finally. Okay, flux, reduce air, flow into place. Nudge. Good, nudge. Good. Looking pretty flat, good stuff. Let's give it a test. The mess right now is horrendous. Here we go. All right. 3, 2, 1. 0.01, 0.02, and it's just going to stay at 0.02, isn't it? Yep. Okay, yeah, it's not going to work, unfortunately. So replacing that chip also didn't work. Well, I'm absolutely gutted about this, if I'm honest with you. I thought it was going to be something easy and simple because there wasn't that much corrosion or liquid damage on the board. I have spent hours on this board. It is not worth it for me to continue investigating. I've marked that we're going to look at it on a live stream. For me, that might be in a few days or so, but for you, that might actually happen now. Here we've got the USB-C ammeter, which is electronic, by the way. You can pick this up, the digital one, in the link on the description down below. Plug it into any USB-C device without power connected, and it simply just tells you what readings you get. It's really, really good. This one, pin 08 and pin 17, is coming up open line. Now, I'd look at this, and I did when I looked at this, and I thought that's really bad because there should be something here. Fun fact, on a Nintendo Switch Lite, those pins aren't actually needed because they're for the P13 USB chip.
TWH_TV.
I see. So it's an itch joke, is it? Let's try replacing some bits. I'm going to start with the max IC. Even though I have all the accurate readings, everything's exactly the same, I'm going to do a max IC, and then I'm going to start changing out chips like the STM chip. I really want to try and get down to the bottom of it, because if I can narrow it down, it'll be another reason why we can fix the 470 milliamp hours, right? Let's just wick this away. All this good stuff here. Which one is this, guys? Is this a 77620? Is that what this is? Well, I'm about to show you guys something. Look how good this stencil is, right? I can use 400 degrees Celsius here. Okay, so what I'm not looking for here is 0.02 or a current or a complete draw. Oh, 0.02. Exactly the same thing. Let's try here. 0.02. You're coming with me. Someone said reboot APU time. I don't think that would be the issue. Yeah, I think there's a short somewhere, but I can't find it. I put my thermal cam on the board as well. The only thing getting hot is BQ, but BQ's been changed already. It's pretty standard for BQ to get hot. So again, we're going to come in with V3TF. There's a little solder ball here that isn't... There we go, got it.
When series ends, I want a Joey Does Earthworm Breeding channel.
What? I've messed this one up, I think. I mean, this needs to do a big hop, skip, and a jump. Mod, thank you so much for the £5. Appreciate you. Right, do your thing. Go. Okay. All right, GG. Get off. You're an absolute fool. That's fine, chat. We go again. Right, don't jump all the way over to the right, because then I know we... Okay, it just jumped. Look at that. Perfect. Right, little nudge. Chat, we're good. Chat, we're fine. Do we get 0.02 or is it going to be something else? 3, 2, 1. Yo. 0.02. Nothing. Hopefully the nozzle doesn't fall off. There we go. Perfect. Oh, that's the wrong side. Oh, I've looked at the wrong chip. Guys, why didn't you tell me, eh? Why did nobody in chat tell me it was the wrong way? Right, here we go. Do we get 0.02 amps or something else? Let's go. 3, 2, 1. Oosh. Wait a minute, turn off, go to 0, 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 go to 0. It's not going to, is it? Let's go Wi-Fi IC. The only thing with these tweezers is they're so big. That's just happened, look. Where did that big cap go? That's the question that needs answering. Is it on my tweezers? It is. Brilliant. I'll be honest, chat, I think we got that nicely in place. Just going to give it a little tap. Yeah, we did. Let's check and see if this works. Yes or no. 3, 2, 1. Pop. 0.02. And they're just going to stay 0.02, isn't it? We've tried, guys, we have tried our hardest with this. I've replaced every single thing. And the good thing is that we're still getting the 0.02, which I think shows that we haven't really messed anything up, you know? Unfortunate that we weren't able to fix it, but some things just aren't meant to be. As always, good practice nonetheless. Let's head on over to Sally's spectacular spreadsheet because there is actually an adjustment that I need to make for last week as well. This is actually the outcome of last week's video. However, the PlayStation 5 that I said I would sell for 150, it didn't. It sold for 120 on auction, so I need to minus £30 from this sell price. So we put this down to 247, which actually gives us a gross profit of minus £1.23 for last week's video. So I'm going to adjust that now quickly, minus £1.23. And then for today's video, well, I don't need to make any calculations because it's straight up a minus £50, isn't it? The reason it's minus 50 is because I'm going to be keeping the board and the chassis and the housing and everything. So that now leaves us with a total profit of the series for £250 and 30 pence. I've got a feeling this is about to get interesting again. Thank you so much for watching this video. If you enjoyed it, hit the thumbs up button, subscribe to the channel if you're new around here. And if you have got to this far in the video, which always baffles me, comment down below saying 0.02 amps, just to remind me of how much I absolutely love that error. Have a great week/weekend and I'll see you in the next one. Peace.